Welcome to a brand new session in MedPhysio Tutorial Series. This is a part 1 of exploration of the cardiac cycle. Before we dive in, take a moment to picture what really happens in a single heartbeat. That rhythmic sequence of feeling, contraction, ejection, and relaxation that keeps blood moving through the body every second of our life. This tutorial will break down that rhythm step by step, not just to help you understand it, but to help present it clearly in exams. We'll start by defining exactly what the cardiac cycle is, why physiologists describe it as events from the beginning of one heartbeat to the next, and how that definition connects electrical activity, mechanical contraction, and pressure changes inside the heart. By the end of this short lesson, you'll be able to 1. Write a concise, high-scoring definition of the cardiac cycle, state its duration with confidence, and outline its major phases using accurate physiological terms. Now, mind you, questions on this topic are almost guaranteed. The key to scoring full marks lies in precise phrasing, like linking the concept to its timing and sequence. So let's begin one heartbeat at a time and uncover the rhythm that powers every function of the cardiovascular system. Let's begin by defining the essence of what happens every time the heart beats. When we say cardiac cycle, we are referring to the entire sequence of electrical, mechanical, and pressure events that occur between the start of one heartbeat and the start of the next. It's not just the muscular contraction, it's the full rhythm of depolarization, contraction, relaxation, and refilling that repeats with each beat. Each cycle begins with an impulse from the sinoatrial node, the natural pacemaker of the heart. That impulse spreads through the atria, producing atrial systole, and then through the AV node and the conduction system to trigger ventricular systole. After contraction and ejection, the ventricles relax during diastole, allowing the blood to flow back in from the atria. Only when the chambers are filled and the electrical system resets does the next cycle begin. At rest, this sequence occurs about 75 times per minute, giving a cycle duration of roughly 0.8 seconds, but it shortens during tachycardia and lengthens during bradycardia. So the timing of the cardiac cycle is dynamic, adjusting automatically to the body's metabolic demand through autonomic regulation. From a mechanical standpoint, the cycle alternates between two fundamental phases. 1. Systole, when the cardiac muscle fibers generate tension and eject blood. And 2. Diastole, when the fibers relax and the chambers refill under low pressure. From a hemodynamic viewpoint, these phases are marked by alternating pressure gradients that govern valve opening and closure, ensuring unidirectional blood flow through the heart. Now, if asked what is the cardiac cycle, do not stop at one heartbeat. State that it is the complete series of electrical, mechanical, and pressure events in both atria and ventricles, lasting roughly about 0.8 seconds at 75 beats per minute, encompassing systole and diastole. Now, that phrasing alone signals a distinction level answer. It's concise, it's quantitative, and physiologically correct. To visualize it, think of the heart as a 4-chambered pump running on perfect synchronization, electrical activation, which leads to mechanical contraction, which leads to pressure changes, and then the valve motion, then there's blood flow, relaxation, refilling, and the rhythm begins again. That integrated repeating sequence is the cardiac cycle, the fundamental unit of cardiac function and the physiological basis of every heartbeat recorded on an ECG. Now that we've seen what happens during one heartbeat, let's define it formally, the way the examiner will expect it to be written. The cardiac cycle is defined as the sequence of mechanical, electrical, and pressure events that occur from the beginning of one heartbeat to the beginning of the next. Each word in that definition carries physiological weight. Mechanical events refer to the actual muscular actions, atrial and ventricular systole and diastole, which are the contractions and relaxations that move blood through the heart. Electrical events point to the depolarization and repolarization seen on the ECG, which initiate and coordinate those contractions. And the pressure events describe the rhythmic rise and fall in intracardiac pressures that open and close the heart valves, ensuring forward flow and preventing backflow. Together, these three dimensions, mechanical, electrical, and pressure, make the definition complete. Leave any one of them out and your answer becomes physiologically incomplete. That's why we call it the triad of cardiac events, and it should always appear in your written definition. It's also important to emphasize the phrase from the beginning of one heartbeat to the beginning of the next. This marks the cycle as a repeating physiological loop, not a single event. The heart does not contract once and rest. It beats in a precisely timed sequence that repeats 75 times a minute on average, adjusting continuously to the body's needs. So if you are asked to define the cardiac cycle, write it in this way. The cardiac cycle is the sequence of mechanical, electrical, and pressure events occurring from the beginning of one heartbeat to the beginning of the next, including systole and diastole of both atria and ventricles. Then you can underline or emphasize the triad: mechanical, electrical, pressure. That single sentence with those key words intact earns the definition mark immediately. Anything shorter or missing of any of the components signals an incomplete understanding to the examiner. Now let's unpack why the cardiac cycle is defined the way it is, and why every phrase in that definition is physiologically intentional. The heart is not a stop-start organ, it is a continuous loop, beat after beat after beat, where one cycle ends only as the next begins. This definition captures that rhythmic continuity, a system that never truly rests while life persists. When we describe the cardiac cycle as a sequence of mechanical, electrical, and pressure events, it's because those three components occur together in perfect coordination. The electrical events, beginning with the sinoatrial node, provide the timing signal as the depolarization that triggers contraction. Mechanical events are the muscular responses, the systoles and diastoles of the atria and ventricles that actually move blood. The pressure changes arise from those mechanical contractions, opening and closing the valves with mathematical precision. Now, without electrical initiation, mechanical activity will be uncoordinated. Without mechanical contraction, pressure gradients will never form. And without pressure differences, valves will not open, blood would not move, and circulation would collapse. So the definition integrates all three, forming a complete physiological narrative. That phrase, from the beginning of one heartbeat to the beginning of the next, identifies one full rhythmic cycle from sinoatrial node firing to the moment it fires again, encompassing both atrial and ventricular activity. This is what allows us to measure the cardiac cycle precisely, typically 0.8 seconds at roughly 75 beats per minute, and relate it directly to time events on the electrocardiogram. The duration of the cardiac cycle is inversely proportional to the heart rate. Now, this integrative view sets the foundation for understanding how we correlate ECG waves with mechanical events, heart sounds with valve closure, and pressure changes with blood flow dynamics. In your written answers, mentioning these linkage, that is, the cardiac cycle definition, sets the stage for studying ECG, heart sounds, and hemodynamics. Shows examiners that you understand not just what it is, but why it matters in physiology. I repeat, in your written answers mentioning these linkage that the cardiac cycle definition sets the stage for studying ECG, heart sounds, and hemodynamics, shows examiners that you understand not just what it is, but why it matters in physiology. So let's put the numbers to the rhythm. The cardiac cycle isn't just a sequence, it's a precisely timed pattern of events that repeats with remarkable regularity. At an average resting heart rate of roughly 72 to 75 beats per minute, one full cardiac cycle lasts about 0.8 seconds. Let's break that down physiologically. The atrial systole occupies roughly 0.1 seconds. During this brief movement, the atria contract to deliver the final portion of blood into the ventricles, the so-called atrial kick. It contributes about 20 to 30% of ventricular filling. 2. The ventricular systole. This lasts about 0.3 seconds. This includes both isovolumetric contraction and ejection phases. Here, the ventricles generate enough pressure to open the semilunar valves and propel blood into the aorta and pulmonary trunk. Finally, complete diastole spans roughly 0.4 seconds. This is the relaxation period where both atria and ventricles are refilling. Ventricular pressure falls below atrial pressure, the AV valves open, and passive filling begins. These timings may vary from heart rate. With heart rate, when heart rate increases, for example during exercise, diastole shortens proportionally more than systole, which means the heart spends less time filling and more time maintaining circulation. Conversely, during rest or sleep, diastole lengthens, allowing more filling time and coronary perfusion. This adaptive shortening and lengthening is a key feature of cardiac physiology, the heart's built-in ability to balance rate with efficiency. Now, when defining or describing the cardiac cycle, always note its duration. A simple phrase like lasting about 0.8 seconds at a heart rate of 75 beats per minute immediately earns you an easy mark and signals accuracy to the examiner. Many students usually lose that mark simply by omitting a number. So, remember, physiology is a science of timing. A heartbeat is not only a sound or a pulse, it's a measurable cycle of mechanical, electrical, and pressure events repeated 75 times a minute with near perfect precision. So now that we understand what the cardiac cycle is and how long it lasts, let's take a quick overview of the events that occur within that single 0.8 second heartbeat. Every heartbeat follows the same fundamental rhythm: filling, then contraction, ejection, relaxation, and filling again. So let's start with the first part, that's atrial systole. The atria contract gently to the top of the ventricles. The atrioventricular valves open, allowing blood to flow forward while the semilunar valves are closed. This prevents backflow from the great vessels. 2 is the isovolumetric contraction. Here, the ventricles begin to contract, but both sets of valves are closed. See? Because all valves are closed, no blood moves. This leads to a rise in pressure sharply inside the ventricles. Then the ventricular ejection. Once ventricular pressure exceeds that in the aorta and pulmonary trunk, the semilunar valves open and blood is expelled into the circulation. Then we have the isovolumetric relaxation. Here, contraction ends and pressure falls. All the valves close again. Momentarily, the heart relaxes but hasn't started filling yet. And finally, you have ventricular filling stage. As the ventricular pressure falls, drops below atrial pressure, the atrioventricular valves open and blood flows passively into the ventricles. So together, these 5 moments make up one complete cardiac rhythm, a continuous alternation of contraction and relaxation that maintains blood flow throughout the body. Remember, feel, squeeze, empty, relax, feel again. Feel, squeeze, empty, relax, feel again. Squeeze, empty, relax, feel again. It's the simplest way to remember the flow of events without getting lost in numbers or graphs. So for now, let's just keep this as your mental roadmap. In the next part, we'll return to this sequence and explore what happens to pressures, volumes, and ECG patterns in each phase. But the foundation is this particular rhythm. Very importantly, let's step into the exam hall where all this knowledge is tested. Questions on the cardiac cycle appear in almost every physiology paper because it is central to cardiovascular function. The good news, it's also one of the easiest topics to score full marks on. That's if you present it in the right structure. Here's the typical range of possible questions you might meet. Define the cardiac cycle, state its duration, list the main phases of the cardiac cycle, or sometimes explain what is meant by one heartbeat in physiology. They're all assessing the same concept, your ability to link definition, timing, and sequence in one coherent explanation. So how should you write your answer? You can follow this 5-mark flow: definition, duration, phases, significance. Definition, write the full textbook definition with the triad, mechanical, electrical, and pressure events. Duration, add that it lasts about 0.8 seconds at 75 beats per minute. Phases, briefly outline the 5 main events: atrial systole, isovolumetric contraction, ventricular ejection, isovolumetric relaxation, and ventricular filling. Significance, conclude with one line linking the cycle to effective rhythmic pumping of blood. That 4-step structure earns you the complete marks, and it shows the examiner understand both what happens and why it matters. Now, common mistakes you should try to avoid. Please don't use vague terms like the heart pumps blood, without any structure. 2, confusing heart rate, that's the number of cycles per minute, with the cardiac cycle, that's the event in one beat. And then lastly, forgetting to mention the duration. That alone can cost you a lot of marks. A good answer tells a story in sequence. A great answer quantifies it, names its phases, and ends with purpose. So when you sit for your next physiology paper, write with rhythm, definition, duration, sequence, significance, just like the heartbeat itself. Let's end this first part with a quick reflective exercise. A short task, to make sure you truly understand the rhythm of one heartbeat. Take a moment to write down your answer to this question. In one sentence, explain why the cardiac cycle runs from one heartbeat to the next. Think carefully before you write. This isn't just a definition test, it's about demonstrating understanding. Well, the expected response is simple but complete, and at least your response should look something like this. It is so because it includes the sequence of contraction, ejection, relaxation, and refilling that occurs once in every heartbeat and then repeats rhythmically. That single sentence shows conceptual mastery. It captures the mechanical, electrical, and temporal continuity that defines the cardiac cycle. Now another one. Sketch a simple 1-beat line. Mark the contraction phase, systole, and relaxation phase, that's the diastole. You don't need a detailed pressure diagram yet. That will come in probably our part 2. Yes. You need just a visual rhythm, up for contraction, down for relaxation. One full heartbeat in one continuous motion. When you are done, you can pair up and compare your sketch with a classmate or a colleague, or review it yourself, checking whether your drawing flows smoothly from a systole to diastole without breaks. That's what makes it a cycle rather than a single event. This activity may look simple, but it reinforces the fundamental truth of cardiovascular physiology, and that's the heart's work is cyclical, coordinated, and continuous. Every contraction sets the stage for the next filling, and every filling prepares the next contraction. That brings us to the end of part 1, definition and foundations of the cardiac cycle. Now take a moment to appreciate how much you've just connected electrical activity, mechanical movement, pressure changes, and the rhythm that sustains life itself. Remember, every heartbeat you hear is a living demonstration of these principles. A perfectly timed cycle that repeats about 75 times per minute, every hour, every day. As you revise, always think in sequences: definition, duration, phases, functional significance. That structure is a roadmap for exam success and deeper understanding. In our next session, we'll explore atrial systole as the first active phase of the cycle and see how it completes ventricular filling and sets the tone for the entire heartbeat. Thank you for learning with us. Physiology is taught not just for exams but for mastery. Keep learning, keep asking why, and keep your curiosity beating in rhythm with your heart.